Why, hello there, everyone. I am part-time scientist Mr. Alex with the Independence Public Library, and welcome back to Science Time. You may notice that the background set is a little bit different today. We've got a big giant heart in the background, fluffy clouds with poofy red and purple and sparkly hearts, and everything's lit up and all pretty and festive, all themed around hearts. Well, that's because this month, February, is Love Your Library Month. It also happens to have a little known day you may have heard of called Valentine's Day, and that ties in pretty nicely as well. And so when you think about this month, Love Your Library Month, and love in general, and you think about people who really have a connection together and people who really, really like each other, you often say they have chemistry. Chemistry. So I can think of no better way to celebrate this month of love and chemistry than with, getting down and working on some actual chemistry. And hey, if this month is all about chemistry, then just call me Cupid, huh? Okay, so for today, what we're going to do is we're going to play around with chemistry and more specifically, some acids. And we're going to use it to make bouncing eggs. And it's really, really cool, so stay tuned. So first, let's talk about what exactly an acid is. So when we're thinking about a lot of liquids, you might think acids. Acids, like in the TV shows, in superhero movies, won't that like melt my skin? Well, there are some acids out there that are incredibly dangerous and that you don't want to touch, but not all acids are created equal. And actually, I've got this nice little scale to help us. This is the pH balance scale, and it goes from 0 to 14. Now, everything between 0 and 7 right here, we consider those to be acids, with the ones closer to 0, closer on the red end, being the more powerful reactive acids. You can see right here, battery acid is number 0. That stuff is really nasty. And on the opposite side, that's not really going to be important for today, but it's interesting to know, these are called bases. Almost the same, like the opposite side of the same coin, acids and bases, they react differently to different things. Almost every liquid can be put somewhere on this scale. Most liquids are either acids or bases. However, if something falls directly in the middle on number 7, we consider that to be pure neutral, not an acid, not a base. Right here you can see distilled water, like the purest pure water, is neutral, not an acid and not a base. And the reason that's important that we've got this spectrum over here to understand is you can see where different things fall on the list. Right there in the middle, water, of course, that's, the neutral. But as we head this way towards acids, we've got coffee right here, that's kind of a weak acid. We've got vinegar, which we're going to be using today, it's a bit stronger of an acid. And then near the end of the list, battery acid, like I said, nasty stuff. And on the bases, we've got, a bit of a base is baking soda. A bit further down, around like 11 or 12, is soapy water. So if you get soap in the water, that's a base. And then near 13, bleach, also nasty stuff. The stuff from like far ends. Yeah, those can be dangerous. But today we're going to be working right around here, between 2.5 and 3 for vinegar. So it's definitely something you don't want to get in your eyes, and you don't want to get on any part that's sensitive. But if you get a little on your skin, it's not going to hurt you all that much. I just wanted to put your mind at ease. Just be careful like you do with everything, and you still probably want to wash your hands afterwards just in case. That being the case, now that we've touched on the pH balance scale and we understand acids on one side, bases on the other, neutral right here, let's take a look at this particular acid, vinegar. So right here, we're going to be using, to make our bouncing egg, white vinegar. You could use any vinegar, but we're going to be using white vinegar for this. So to get started, it's really, really easy setup. All you're going to need is an egg, raw egg. No tricks here. This has not been hard-boiled, cooked, or modified in any way. Brand new raw egg. And we are going to put it into the cup. Glass, next thing we need. Put the cup in the glass. and we're going to submerge it with the final ingredient, our white vinegar. Now be careful when you do this. If you're pouring this, either get an adult to help you, helpful adult, or make sure that you do it over a sink. You don't want to make a bit of a mess. And you want to pour just enough in to submerge the whole egg. Ooh, I can smell that. And not much is happening right now. If I were going to put a fourth requirement for this, the first ones being egg, glass, vinegar, the fourth requirement would be time. Because we're going to need time for this reaction to take place. Although if you were to zoom in, you can see that already the vinegar around the eggshell is starting to bubble up. Now that's going to get only more powerful as time goes on, but for right now we've got little bubbles encasing the whole egg. And if you've done this already, you can see that for yourself. You get way up close, you can see it start bubbling all over. Now what that is the acid vinegar, the vinegar being an acid reacting with the eggshell, in particular something we call calcium carbonate, which is the outside of the egg. And it's reacting together and it's creating carbon dioxide, which you might know as some stuff that floats around in the air. Part of the air is carbon dioxide. It's releasing that off of the egg after interacting with it. That's what's causing it to bubble. That's the carbon dioxide escaping from the eggshell. It doesn't take long at all for it to get started. But in order for the egg to become bouncy like we want it to be, it's going to take a little time. So your best bet is to take this and put it in a safe place where it can stay for some time, several days in fact. So we'll set that aside and we'll check up on that later.
Okay, everybody, it's been about 72 hours, so let's take our egg and give it a look. It's been in the vinegar for about 3 days, and as you can see, there's a little layer of foam where the vinegar was. From foam and gunk on the top, and also the egg has still got a little bit of bubbles on it. So we're going to drain the vinegar real quick with some warm water down the sink. And once we've got all of the vinegar out, we're going to grab our egg and take a look at it. As you can see, it's got this weird white powder on it that's a result of the eggshell having reacted with the acid. Going to turn down the heat on the water a little bit, and then in the warm water we are going to try and rinse the egg and get all of that white gunk off. As you can see, a lot of it's already starting to come off, and it's leaving behind a semi-translucent skin. You can kind of see through it to the egg yolk and the egg whites on the inside, and the whole thing feels kind of squishy. Okay, so for the grand finale, here is an egg I have taken straight from my fridge just now. Raw egg, not touched at all, and here is our vinegar egg. Look at the size difference on that. And if you see, if I try to squeeze the left one, it's really hard. If I squeeze the right one, it's squishy, hard, and I can't do anything. Squishy, squishy, hard, hard. And so now, if you've got a bowl or a plate or something that you could use, it's time to have fun and start bouncing our egg. You can grab it, feel around on it. You can feel that it's very, very, very squishy, and it looks very different than an egg that we would have started with. Squish, 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 squish. It's like a little stress ball. Woo! Look at it go. It's like a little rubber ball. This thing squishes very well. It's almost a stress ball, but don't squeeze it too hard. It is raw. You have to remember, this will pop if you were to squeeze it too hard. It's almost like a little egg water balloon. And you also, from before, notice that it's way bigger than a starting egg. Those two eggs were about the same size when we started. But through a process called osmosis, the water from within the vinegar that the egg was sitting in transferred itself from outside of the shell and went into the shell of the egg. Eggs shells have what we call a semi-permeable exterior, so only some things can pass through it, one of those things being water. thus making it this big.
Wow, wasn't that cool? It's amazing. It's just wild how different the eggshell is based on, before we do the experiment and after we do the experiment. Like, your eggs probably aren't done yet if you're watching this video for the first time, but as you've seen just now, after just 72 hours, that eggshell is like a completely different material. And that's because it kind of is. After the reaction where the acid in the vinegar was reacting with the calcium carbonate inside the eggshell and then transforming through the chemical reaction into carbon dioxide and escaping into the air, it fundamentally changed the makeup of the eggshell, making it bouncy, making it kind of squishy and rubbery. You could fool someone into thinking you hard-boiled that egg, but if you were to lift it high enough and drop it, splat. So just be careful about that. On that note, I would encourage you to try different experiments with this, because this is how the egg worked for us using just white vinegar and for 72 hours, about 3 days. But you could ask, what would happen if you did it shorter? What if we took it out a bit earlier, maybe 48 hours, maybe even 24 hours? Would that be enough for it to be bouncy? What if we left it in longer? Would it be even more different? These are the kinds of experiments that you can think up. I encourage you to think of cool different ideas that might change the outcome. In fact, we've actually got in the background 3 other experiments going on at the same time. As well as the white vinegar one that we used for this video, we're also trying apple cider vinegar, rice vinegar, and balsamic vinegar. So all different vinegars, different acid levels, but will it be the same? Will it be different? That's the really, really cool thing about science, trying to figure out why things work by trying slightly different things, slightly different approaches, and seeing what changes. So I encourage you to do that. Play around with putting it into other household acids. If we pull out this chart again, of course, we're staying away from the dangerous end. Nothing down here. Anything about there? I don't expect that you're going to have many of these in your house, but I just want to let you know that up front. But for vinegars, like I said, we're using 3 other kinds of vinegar. And then also another good idea is if you've got lemon juice in your household. Lemons and other citrus fruits are amazing acids. They are great household acids for if you want to do experiments. So you could do the exact same thing, put the egg into the cup, and then pour in lemon juice. And then you could see, would it be the same as the vinegar? Maybe different? How so? I encourage you to try it out and have a whole lot of fun doing so. And along with this program, we've got a lot of other really, really cool stuff coming up for February's Love Your Library Month. So check out the Independence Public Library's Facebook page and take a look at what's going on this month. I hope that you had a lot of fun and hopefully learned something really cool and got to play around with a really fun bouncing egg. And on that note, I will see you guys later. Take care, everyone. Bye-bye.
And here we have the 3 other eggs that we're testing out in the 3 other vinegars. How do you think these eggs are going to turn out? If you have a hypothesis, leave it down in the Facebook comment section of this post. We would love to hear what you guys think. And be sure to test it for yourselves. Have a happy science time, everyone.